All right, so welcome everyone. Thank you for joining my webinar. My name is Michael.fainberg. I'm a patent attorney. I have engineering background and I have been practicing patent law for over 25 years now. And in the past 10 years, I've started to see more and more patent applications that involve AI and machine learning technologies. And in the past couple of years, there has been an explosion of new patent applications for generative AI technologies. So I decided to share my experience in this area and discuss various trends and strategies for patenting AI and machine learning technologies, which obviously is a very hot area right now, and it seems there's a lot of interest in it. So let's start. First, I'm going to give a little overview of what is intellectual property law is for those who are not familiar with it, and various forms of intellectual property protection. So we'll start, and they arranged in the form of basically cost to make it easier. So intellectual property is a category of property that includes intangible creations of human intellect. So unlike physical property, like a house or a car that you can buy or build, and you own it, and you can sell it, and you have a right in it, you have a deed in a house or a contract in your car. Similar applies for creations of human mind. So one form of intellectual property protections is trademark. And trademarks is typically used to protect confidential information. And the way it applies to intellectual property, to uh, artificial intelligence and machine learning technologies, is that you can protect the trade secrets, various AI model architectures, AI model parameters, and we'll discuss more about it later, or various training data sets. And as long as you keep this information secret, you have all your employees sign non-disclosure agreements, and you take appropriate measures of control of this confidential information, you will get protection under law for this form of intellectual property. And you can keep this indefinitely. Okay, and there's no really cost of registration because you don't register anything. You just have to keep it internally within your company as a trade secret. Then there is a copyright. The copyright protects original work of authorship. And typically books, music, movies, and with respect to software and artificial AI technologies, you can copyright source code, you can copyright LLM prompts, you can copyright training data sets, you can copyright user interfaces and various forms of documentation and manuals that you use in your business. So, and the criteria for registration are originality and creativity, and you can register it at the Library of Congress. The registration is very cheap, a couple $100, and once registered, you own the rights for this works of authorship for a lifetime of the author plus 70 years. The next form of intellectual property protection are trademarks. And trademarks are used to protect words, phrases, symbols, or designs uniquely identifying a service or product. And with respect to AI technologies, there are examples here, you can trademark the names of your products or your companies, like, for example, OpenAI and that little flower design are copyrightable. The term OpenAI, the name OpenAI, I think there's a patent application pending for it. They haven't copyrighted it yet, I believe. And the ChatGTP, even the word ChatGTP, the company also filed a trademark for that word, for that phrase, ChatGTP. They have trademarks for DALL-E. There are trademarks for XI's Grok, and of course there are trademarks for Google and their product Gemini. So this form of protection is more costly. It costs a few $1,000s. And the reason for it is just there are more criteria for registration, and you need to register it at the United States Patent Office and Patent and Trademark Office. And there are criteria of distinctiveness. It has to be not confusing and it has to be used in commerce. And as long as you use the trademark in commerce continuously, you own the right in that trademark. And the last form of protection, and it's considered the most rigorous and the strongest form of protection, are patents. And patents are used to protect inventions, and it gives you a right to exclude others from making, selling, or using your invention in the country, particularly in the United States or any other country where you file your patents. And what's covered under patents are functional these inventions, functional technologies. It's devices, system, processes, methods for doing business, data structures, algorithms, and in case of artificial intelligence, you can patent AI models, architectures, you can patent graphical user interfaces. And this is the sort of the most expensive form of intellectual property protection. It ranges in tens of thousands of dollars. And the reason for it is because the criteria for registration are quite rigorous and high. It has to, first of all, the invention has to be patent eligible. You can't patent everything. It has to be new. It has to be non-obvious, and it has to be reduced to practice. You cannot patent an idea. It has to be actually described in detail in your patent application and in your patent eventually, so anyone with the skill in the art can reproduce the invention without undue experimentation. So there are quite rigorous standards for patent protection. And another reason why patents is generally considered the most strongest and the most effective form of intellectual property protection is because it gives you right to exclude others. So even if someone independently came up with invention, which you were first to invent it and patent it, you can exclude others. This does not apply to other forms of intellectual property protection. For example, with trade secrets, if you keep your AI model secret, okay, then if someone else comes up with the same AI model and independently starts selling or using it, you cannot stop them from infringing on your trade secret because they did not steal anything from you. They independently derived it. Same thing with the copyright. If someone independently comes up with a very similar code or very similar LLM prompts, you cannot really assert copyright because they did not, copy it from you. They derived it independently. Whereas with patents, there's a much broader scope of protection. You can, even independent inventions by others, you can still assert your rights to exclude them. Okay. So now we're going to delve more into the patents, the more technical aspects of it. So let's see what's going on with the patenting of AI-related technologies in the United States. And basically, the term AI was coined in the 1940s and 50s, and then in the 60s and 70s we started seeing a computer revolution happening in the United States, and first the server computer has been developed, mainframe computers and personal computers, and people started thinking how they can make computers think like humans, because human have very strong reasoning powers. So let's make computers think the same way. And that's where sort of AI picked up, and first neural networks were developed, sort of replicating new neural pathways in the human brain, and various data classification algorithms and regression models have been deployed and implemented on computers using circuitry or using software. And so starting in 1970s, first patent applications have been filed and patents were obtained for AI-related technologies in the United States, particularly. And the growth of AI-related technology has been very slow, till the beginning of this century, because the computers were not powerful enough to implement and execute those algorithms. They were not very practical. But since the rapid increase in processing power, starting this century, there's been a surge in patent filings for AI-related technologies and innovation in the field of AI this century. And we can see there's a surge in patent filings starting from around 2000s. And right now we have about 350,000 patents in the US for various AI-related technologies. And particular growth we've seen in this chart in the past 10 years, particularly with the surge of generative AI technologies and popularity of that technology. And we can see that, like like every year there's a significant increase in patent filings and significant increase in innovation in this area. And as with any new technology, patent office was sort of very skeptical, and they didn't know how to analyze AI technologies, and the rejection rate initially was pretty high for patent applications for AI and machine learning technologies. So it was around 30s and 40%. But over time, we see the rate of as the patent office becomes more sophisticated in analyzing and examining AI-related technologies. We see increase in the allowance rate and the grant rate of patents. It's around 60%, which is a sort of standard rate for the patent office generally, whether it's mechanical inventions, electrical, software, pharmaceutical, chemical, we see around 60 to 65% allowance rate. So right now it's a sort of mature technology, and it's not easy, but it's possible and to get a patent and with a good likelihood for AI related technologies. So now we looked at generally that patents are being filed. Let's see who is filing patents in the United States. And here's some interesting statistics. And for top patent filers for AI-related technologies in the U.S., and we see, of course, U.S. companies, computer and internet companies, software companies, Alphabet, Google, IBM, leading, and Microsoft. Then we have, on the left here, we have sort of companies organized by categories. Then we have Chinese tech companies, Baidu, Tencent, and Pinyin, filing a lot of patent applications in US for AI-related technologies, then followed by Korean companies, Samsung, LG, and then Japanese companies, Sony, and Toyota, and then European companies. Sort of what's interesting to notice is that in each of those sort of categories, we see companies in different technology areas patenting for AI innovations. And as we know, US is very big on in the IT sector, software, computer technology. So we have this technology, US computer giants, Google, IBM, and Microsoft filing for a large volume of patent applications for innovations in AI technology in the computer field. Then in Korea, we don't have as many computer companies. Koreans has been known more for consumer electronic companies and automotive. So we have Samsung, LG, which are consumer electronic companies, and Hyundai, which is automotive company, filing for AI patents in their sector, in their technology sector. And then we see the same for Japanese companies who are known for the innovation in the sector of consumer electronics and automotive. So we have no wonder that Toyota and Sony are the biggest patent filers from Japan. And finally, Europe, which is kind of behind US in computer and IT technologies and not as advanced as Japan and Korea in consumer electronics, but they're big on industrial systems and transportation and consumer appliances. So we have Bosch and Siemens as leaders from Europe in the AI innovations in their respective sectors. So now, once we saw who is filing for patent applications in the US, let's take a look at what is being patented. And what I've done here, I broke all the AI technologies into three categories, and that's how the patent office organizes them. And the first category is patents for AI techniques. And by techniques, I mean advanced statistical and mathematical models used in the AI technology. And here's the major five categories: fuzzy logic, probabilistic reasoning, machine learning, ontology engineering, and logic programming. And we've seen everyone knows about machine learning, and in fact, it is the biggest category of patent filings. Most patent applications are directed to inventions in this particular field. And we can see about 40% of patents, more than actually 40% of patents, are for machine learning technologies. And specifically, we see neural networks, deep learning, support vector machines, classification and regression models, and then, of course, various training techniques for machine learning, supervised learning, unsupervised learning, reinforced learning, and multitask learning. So this is generally how all patents are organized in the US Patent Office. Then we can look at another, For another prism, it's a functional applications of AI technologies. And here we see, again, that's how the Patent Office organizes all patents and all patent applications. And here we see a category of predictive analytics, speech processing, distributed AI, robotics, natural language processing, and computer vision and control methods. So the biggest categories are computer vision, and within that category, about 40, we say almost 50% of patent applications for AI technologies are in this technological area. And within that, we have subcategories of biometrics, object tracking, augmented reality, image and video segmentation, and of course, natural language processing. So computer vision has been around for a long time. So we have the most number of patents in that field. And then, as of recent, there are sort of new areas emerging, and natural language processing has been extremely popular, especially with the advancement in the generative AI technologies, which were, came around in the past 10 years. So we see a surge in, of course, patent applications for NLP, natural language processing inventions. And right now, it's about 15% of the entire AI patent applications. This is those 350,000 I mentioned before. And within that, we see machine translations, dialogue, information extraction, morphology, and semantics, some of the subcategories. And of course, speech processing is also a very popular area. And we see speech recognition, speech synthesis, speech-to-speech, it's translation. So these are the areas of popular areas of functional applications of AI technologies that are being patented. And one more category we can look at it is the field of applications of AI inventions as recognized by the US Patent Office. And here we can see networks as a popular area where we have patents for smart cities, social networks, Internet of Things. We have business and banking, finance area, various e-commerce application, fintech, customer service, enterprise computing. Then life science and medical devices is a huge area of patenting. And we see this bioinformatics, medical information, biological engineering, genetics, and drug recovery. And transportation is a very big area of patenting, and it's involved. Here we see traffic engineering, automotive driving, vehicle and driving recognition, and so on. So here's some of these most popular areas of fields of application of AI technologies that are being patented. Okay. Now let's look. So now we looked at generally AI. Now let's look something more specific. Let's go deeper and look at the sort of the newest trends in innovation in the field of AI. And of course, it's a generative AI, Gen AI. And this field sort of exploded in the past 10 years. And this is this graph, which was generally provided by the World Intellectual Property Organization. And this shows not just US patent filings, but global patent filings across all national patent offices. And the biggest, of course, patent offices being US, China, European Patent Office, Korean Patent Office, and Japanese patent offices. But, all countries have patent offices. So this is statistics from the World Intellectual Property Organization. It shows the rate of sort of innovation and patenting in the area of generative AI. And we see, according to them, Chinese companies lead the world in the number of patents, in not just in number of patents filed for generative AI technologies, but also in the research in generative AI field. About 38,000 patent families, which include several patents that the family is, for various generative AI technologies. And here in this graph, there are two interesting points I want to mention. So something happened in 2017 that sort of gave a boost to the in the field of generative AI. We see it was sort of in 2014, in 2015 and 16, we see some research and patenting in this area, but then something happened in 2017. And I don't know if you can guess, but I'll show you. Basically, in 2017, Google announced its transformer architecture neural network, and that was, which later was used as a fundamental technology for most large language models we see today. And that's sort of the release of this paper and release of this architecture gave this a very powerful motivation for AI community to develop various generative AI models and applications. And then something else happened in 2022. I think it would be easier for you to guess. And let me show you. Of course, OpenAI releases ChatGPT chatbot, and its model is an open source and is a product. And we can see what happened the next year. The rate of research in area of scientific publications in the area of generative AI basically skyrocketed. You can see the gold bars from between 2022 and 2023. And although we don't see the same increase in the blue bars on the left, but the reason for it is because it takes about 18 months for patent applications to issue, or to get published, and even longer for it to issue. And that's why we see that the blue bar is not there yet. It takes probably in 2024, once we get data for 2024 and for 2025, we will see the same probably increase in number of patent filings in the field of generative AI. Okay, let's continue. Now let's see who files patent applications for generative AI technologies. And right now, as not surprisingly, Chinese companies lead the world with Tencent, e-commerce and internet company, Pingyang Insurance Group. It's a fintech, like it's a big conglomerate which files a lot of fintech applications and internet-related applications. Baidu, against its Chinese tech company. So they filed the largest number of patent applications, both in China and internationally, and then followed by the U.S. U.S. technology companies, Google and Microsoft and IBM. But it's sort of this statistics, the patent filing statistics is not really representative of it's not really representative of the reality. Chinese companies file more patent applications, but after all, US leads the world in AI innovations, and particularly because US companies develop most foundational technologies, like foundational machine learning models, like the transformer architecture that I mentioned before, and the ChatGPT, again, was created obviously in the US. So, and plus they lead the world in these industrial standards, and basically the leaders in AI innovation. And also the way US spends 10 times more than Chinese companies on the AI innovation. So even though the number of patent applications is larger, the US companies sort of lead the world in that area, in the innovation in AI technologies. So now that we looked at generative AI, let's see how it evolved in generative AI technology. And so what happened here, we're going to quickly overview some of the key generative AI technologies and some patents for it. So what is generative AI? It's the AI technology that generates new content, image, text, sounds based on training and existing data. And sort of the oldest, and it's been around for a while, and the oldest technology within that area is the generative adversarial networks. It's sort of, since it's the oldest, it's the most patented technology, and it has a very wide range of applications, including image, video, audio generation, text-to-image synthesis, and data anomaly detection. It has a very broad spectrum of applications. That's why it's so popular, and it's sort of one of the oldest ones. Then we have variational autoencoders. It's the second most patented technology, and it's primarily used in image generation, anomaly detection, and data compression. And we will see that a lot of these technologies overlapping in their applications. It's just some of them are better for some things and others are better for other things. Then we have recurrent neural networks. It's been a very popular technology, but with the advent of the transformer models, this technology sort of, has been on the decline, and it shows weakening trend in patenting, and it was historically used for music composition, speech synthesis, and predictive text input. And sort of one of the hottest new technologies is diffusion modeling, diffusion models, and it exhibits the strongest patent growth, and specifically it's used for high quality image generation. So it complements the GAN technology, generative adversarial network, which are also used for image generation, but diffusion models are specifically good for high quality image generation, and they're very popular nowadays. And then, of course, the transformer architecture is sort of foundational technology that is used for all large language models nowadays, and it's specifically created for natural language processing applications, text generation, translation, and summarization. And it was again developed by Google and published in a paper. Attention is all you need. Actually, I highly recommend to read this paper. It's a very entertaining piece of technical reading. And this is the basically picture of their right here model that they developed. This is the transformer architecture, and the left side is the encoder and the right side is the decoder, and it is used, and the sort of key invention besides the organization, it's this attention mechanism. And the way it works, and of course it's been not just published, it has been patented, and there's a family of patents covering this architecture and various uses of it and various permutations and implementations of this particular architecture. And the reason, and it's sort of this architecture gave a boost to large language models. All current large language models are based on this architecture or variations of it. Okay, and why is it became so popular and useful is because this multi-head attention mechanism that manages to use for semantic analysis of text and to track and capture long-term dependencies and relationship between words. So before transformer architecture, it's the generative adversarial networks were used for data processing and recurrent neural networks, not for data processing, for text generation and for semantic analysis for text. But these models are not as good for keeping track of words and meaning of words over a large body of text. It's good for short passages. But this architecture was specifically created by Google for their translation service. Google Translate, we'll remember, it still is a very popular product. And the way it works, the input is basically text, then it's being encoded, converted into matrices or vectors of matrices with thousands of parameters. Then the multi-head attention mechanism analyzes the text, analyzes the input text, and tries to understand its meaning. So, for example, if the sentence, I reached the fork at the road, this multi-head attention mechanism will understand that the fork is not the fork that you eat with, it's something else. It's a split in the road. Okay, that's where the meaning of the words is contained and tracked. And the forward neural network, the blue part, is basically the enormous, very deep neural network, which stores basically all the knowledge that humanity has. Well, depending on the size of it, how well trained it is, but that's what it's for. And so the input goes in here, and then the output, the decoder part, once the text is understood, it generates the output and outputs it. And again, what's important to note, this architecture was created by Google for translation purposes. And then it has been modified by pretty much every other company, including OpenAI, including Google itself, Microsoft, Meta, Baidu, XI, and Tencent, to develop their own large language models, sort of roughly based on this architecture. And which are used for very popular chatbots. Okay, let's look. So let's look at one of the case study, OpenAI patent portfolio. So OpenAI hasn't been around that long, only a couple of years, and it sort of emerged out of nowhere, and no one knew it existed until it released its chatbot. ChatGPT, and basically they have a rather small patent portfolio. First of all, they haven't been around for a very long time. Plus, so they have 14 patents and a few patent applications, a few more pending patent applications. And most of their technology patents are directed to the technology that they actually, sell. Okay, so first of all, it's patents related for the ChatGPT, the generative pre-trained transformer architecture. Then they have patents for multimodal AI. It's basically how they analyze various forms of input, text, images, and audio within their system. Then they have patents for automatic coding, which includes technology for AI-driven coding and programming tools. Then they have patents for speech recognition and processing that's used in their models. And of course, they have patents for their DALL-E product, for the image processing chatbot. So it's a very sort of strategic patent portfolio. And interestingly, OpenAI is not a fully open source company, but they according to their mission statement on their patent website, they say that they will not enforce their patents and they only use them defensively. So, and plus, they have licenses that you can license their technology sort of as open source or semi-open source. And interesting to notice for us patent attorneys is, so there was a Google, of course, transform architecture, yet OpenAI managed to patent, create, invent their own architecture based on Google's transformer, and plus they managed to patent it. So I mentioned some key differences between OpenAI GPT architecture and Google's transformer architecture, which enabled OpenAI first not to infringe on Google's patents, and second to patent their own technology, which is different from Google's technology, yet maintaining obviously the same core principles created in Google's transform architecture. And so one of the primary differences is that while Google Transformer was created for translation functions and sort of the way it was organized to optimize translation from one language to the other and back. That's why they have the encoder and decoder part. Or ChatGPT is not tailored for translation. It's tailored for analysis of text and generation of new text. So what they did, they just dropped one of those branches and they only left the decoder part. So in their architecture, there's only decoder part. So roughly just this part. There's no encoder. And also some of the more detailed, more differences in the context generation, about the way the transformer model works. So basically, they took on Google's model and they changed it. And that's how they managed to overcome, not to infringe on Google's patents, and at the same time managed to come up with their novel technology innovations that they patented themselves. All right, so now let's take a quick look at what my firm and we've been doing in the field of AI recently. And again, as I said, we've been doing AI, we've been filing for patent applications, obtaining patents. We have around over 200 patents for just within my practice group for various AI-related technologies. And some of them are training and fine-tuning of large language models. Then machine learning models used for malware and spam detection. Then distributed deployment of LLMs, large language models, for example, where training is performed on the server side and inference is performed on the client side. There's obviously some interesting interactions going on there and system design. Then the machine learning models for image processing, autonomous driving, then enhancement of large language models with retrieval augmented generation. And we'll talk about this a bit more about later. Then knowledge distillation, very popular technique. Then large language models for scientific discovery and educational applications, and virtual reality, augmented reality, and of course, speech recognition and synthesis, and of course, another popular area of using machine learning models for healthcare and wellness applications. Okay, so now let's look at where the future of AI is going. And what we have here is the current state of AI technology is this compound AI systems, which perform specific complex tasks. And here's sort of like a rough diagram of what is currently products that you see being used, commercially used. So we have a user interacting with a large language model, which performs input and output and natural language processing tasks, basically understanding human speech. And then there is at the heart of the system is an algorithm, right? It's a programming control logic, software code, which basically runs the whole system. It's basically if, then, else, and loops, okay? And it's sort of very linear. But you receive the input and it does specific, and the algorithm tells the system how to perform this task step by step. So, and there are various components. The because it's a compound AI system. There are various components working together. So, for example, if there are private and public databases, which can be used by the LM system, to retrieve various private or public data in order to analyze the input and output, okay, to understand what's being input. Then there are support vector machines, which are various data classifiers and regression models, which may be necessary to perform non-language specific analysis, okay, various image analysis or other things, or perform very statistical analysis on data. Then we have machine learning models, which could be various voice recognition systems, image modeling, tools like these diffusion models that I mentioned before, which do image analysis. Then we have various other tools. For example, web search engine, calculator, image editing software, various sensors that the system might need to use to perform various tasks, which cannot be performed by large language models because those are limited to natural language processing, not for calculations, okay, and not for image editing. The LLMs cannot do that. And then we have, of course, access to the web, where the system can go to the web to find some, current data. For example, if something involves weather and forecasting, the system can go on the web and find out what the weather is in order to answer the user's query. Okay, and all this is done by the algorithm. It communicates with all these tools using APIs, and the LLM communicates with the public and private databases using retrieval augmented generation models. So this is what we have right now. This is state of the art, and this is what most of the patent applications which we filed and patents that we received were roughly for this type of system architecture. Okay, now we're looking at the near future, and it's, of course, agentic AI. And what happens here is, let me change so we can run animation. Basically, this changes. The system remains the same. Architecture, the system remains the same. It's just at the heart of the system, it's no longer a code, an algorithm. It's an AI agent. It's an LLM. And an LLM can be trained, an LLM can adapt. So now the system does not perform a specific task, but it can autonomously complete various tasks, solve various problems, and even make some decisions. And this is where, near future, we don't have that many real AI agents yet. A lot of people claiming them, but it's very early stages of development. Okay, and here basic LLM dynamically directs the entire process and all the tools. It maintains control over tasks. It performs error checking. And of course, this is now requires significant computational resources because all these LLMs, they could be different LLMs trained for different aspects. So if this, let me switch to pointer. If this LLM performs natural language processing, this LLM runs the whole process. So it's totally different LLMs and requires a lot of training, a lot of computational power. And that's why we have so much right now in the investment in the AI infrastructure going on across the United States, all these data centers being built, all the AI farms, server farms, because these types of processing requires enormous amount of training and power to perform these tasks. And then we're moving into sort of more distant future, of course, artificial general intelligence, AGI, and it will replicate human-like cognitive abilities, such as reasoning, problem solving, understanding complex concepts across diverse domains. And we're not there yet. And we don't even know what the architecture for this AGI will look like. It will be obviously more complex and more flexible than the existing system architectures. So, we'll see in a few years what's going to happen in this area. So we have a few more slides. Let's see. Okay, so what are some of the challenges of patenting AI inventions? As I mentioned before, there's a 60% grant rate for AI-related technologies, which means 40% of applications being rejected by the patent office, which is kind of a lot. When people spend $10,000 or $20,000 to prepare file a patent application, there's this 40% chance that it's going to get rejected outright by the patent office, which is pretty high. So the reason for rejections and some of the challenges for patenting AI technologies is that, again, that the U.S. patent law system is quite intricate. It involves multiple layers of legal, technical, and procedural rules because U.S. patent system is over 250 years old, and it evolved over time, and it has to adapt to new technologies. In the last century, there was a big push for computer technologies and software innovation in software field. So the patent system adapted from analyzing mechanical and electrical inventions to analyzing software technologies. Now we're moving into the area of AI, and again, the patent system have to adapt to properly examine and grant patents in this field. So to encourage innovation, but to be under control. So you don't give patents to everyone, not to discourage, lawsuits. So some of the criteria for patenting are patent eligibility. Not all inventions are patentable. For example, it has to be invented by human. So for example, if you ask ChatGPT to create a cure for cancer, and let's say it does create it, okay, and it spits out some kind of formula and some kind of chemical formula for some kind of drug or some kind of uh, process for treatment, you cannot patent it because you did not create it. So that's one of the criteria. Okay, so then there's novelty. It has to be new. Invention has to be new. No one has hasn't been done before. It should be non-obvious, which means it cannot be some minor obvious modification to existing technology. And it has to be reduced to practice. Basically, description has to be thorough enough and detailed enough to enable someone skilled in the art in this area to just read the patent and reproduce the invention. So these are quite, and there are, articles and books written on each of these topics. And of course, there are, thousands and thousands of cases, litigation, court cases involving disputes about the meaning of these terms and how it applies to different technology areas. For example, novelty for AI inventions could be treated different from novelty for electrical inventions, and reduction to practice could be different standards for will be applied to patent applications in the field of software than to mechanical, and so on. And so generally about according to the Patent Office statistics, U.S. Patent Office statistics, 77% of all AI-related applications are rejected on the first pass at the Patent Office. And the primary reasons for rejection is sort of insufficient description of AI models. And for example, there's no description of training data sets. There's no description of AI, how the AI model solves particular problem of prior art. There's no description how AI model improves on the computer technology. Those are sort of reasons why patent applications in this field get rejected. And another area of reason for rejection is that claims of the patent applications are directed to abstract ideas. And we'll briefly discuss this in the next slide. Okay, so generally you need very experienced patent attorneys who understand the technology and understand the law to prepare quality patent applications. So patent eligibility tests for software and artificial intelligence and machine learning technologies fall squarely into the category of software. So this is the test basically promulgated by the US courts and by the US Patent Office, and how to assess whether your invention, your software invention, is patent eligible. And so one of the reasons that many AI-related inventions are not considered patent or rejected for being not patent eligible, because the Patent Office considers them to be abstract ideas. And what is considered as abstract ideas are not patentable. And how the courts define abstract ideas are mathematical concepts, so mathematical relationships, mathematical formulas, and mathematical calculations, certain methods of organizing human activity, and mental processes. And with respect to AI models, they often fall within these two categories, because all AI models, if we, for example, look at this model, right? And at its core, it's basically, for example, the feed-forward network, right? This blue module. It's basically thousands and hundreds of thousands of matrices containing numbers, weights, parameters. and the whole what's happening inside, the way you sort of analyze data, it's you add and you multiply those matrices. So they're basically a mathematical concepts. Also, another reason is this: a lot of these AI tools fall within methods of organizing human activity. For example, we've heard of a very popular example a lot where AI agent would book tickets for you, right, online. Well, booking tickets online is the method for organizing human activity. So it's very important to properly describe your invention, to properly describe your AI model, to properly describe your system, how your AI model interacts with various components of your system, and so it does not, and properly claim your invention, so it does not fall into this abstract idea, exception to patenting. Okay. And pretty much I'm wrapping up here. So if you want to read more about patenting of AI or just general patenting of various emerging technologies, you can follow this link. We've done a lot of publications in this area. For example, this is one of the recent publications about AI legal landscape. This is not limited to patents, but more generally what's happening. Then we have patent publications on patenting of a global perspective, what's happening in different patent offices, how they treat AI and machine learning technologies. Then we have articles about U.S. Patent Office, how they treat and how they process AI innovations and patent applications for this area. Then we have publications about patenting of Web3 technologies, blockchain, crypto, decentralized finance, metaverse, and NFTs, and so on. So you can read more if you're interested about this aspects. And this is it. And generally, this is my AI and machine learning patent team. And myself, I have a computer engineering background in telecommunications. I patent over 1,500 patents, and you can scan this QR code to see all of these patents on the U.S. Patent Office website. Over 200 patents for AI and ML-related technologies. You can search within the list of patents by just keywords for things that interest you. And I manage a team of patent attorneys and agents who specialize in software and patenting and writing patent applications for software inventions, and with a lot of experience in AI and machine learning technologies, all of whom have electrical engineering backgrounds and a lot of years of experience of being in patent field. So this is it. If you have any questions, I'm going to run the question and answer here. If it's going to work, for some reason it's not working. So you can ask your questions in the chat if you like, and I can answer. Or I don't know if you can unmute your microphone, please try that. I've never used webinar function yet, so I'm sure you can use chat. But if you don't have any more questions, please feel to write me. You have my email here, your LinkedIn contact, and the phone number. I'll be happy to answer. And of course, if you want to patent your technologies, please reach out to me. All right. Thank you very much for your attention. And we're going to run more webinars on other aspects of patenting. And I will, we'll make an announcement. Okay. Thank you very much. So if you like a copy of some of the presentations and questions, please write directly to my email and I'll answer you. Okay. Thank you very much.